In this video, we will review graphing. You'll need to know how to sketch these basic graphs. First of all, obviously, a linear equation has a slope of m and a y-intercept of b. Then any equation where the exponent is even will be a parabola-like graph with both arms upward. As you get to a higher exponent, it just gets skinnier. And then any exponent that's odd will be one arm up and one arm down. So the basic graph looks like this. Y equals square root of x will look like this. If you need to get specific as far as points go, you can try 1, the square root of 1 is 1, and then the square root of 4 is 2. That'll help you get more accuracy with your graph. Y equal cube root of x is similar, but this one is shaped this way. And we can do the cube root of 8 is 2. Cube root of 1 is 1. Cube root of -1 is -1, and so forth, if you need more accuracy. Absolute value of x is a V shape. And the right side has a slope of +1. And the left side of the graph has a slope of -1. You may want to be aware that absolute value will reflect any point that's below the x-axis above the x-axis. So it's kind of fun to look at the absolute value of, say, the cube root of x. If you had to consider that, that would be your cube root of x graph that's above the axis, but then the stuff below the axis is sent above the axis. So also it's kind of fun to look at the sine curve and then the absolute value of the sine curve. Y equal 1 over x has asymptotes at x equals 0 and y equals 0. So this graph looks like, those are my asymptotes, looks like this. And then also, if you notice this exponent is odd, if you were to look at 1 over x cubed or 1 over x to the 5th, they also have that same basic shape. And then y equals 1 over x squared also has asymptotes at x equals 0 and y equals 0, but this time the basic shape is like this, sort of like a volcano. And it's interesting, we set up here that absolute value reflects a point that's below the axis up above the axis. Squaring does the same thing, but it also changes the graph a little bit in that it stretches it. So you won't have anything below the axis when you square a graph as well. Now let's do a few transformations. If we were to graph this one, we know that y equal x squared is the both arms up. And then this minus 3 part makes the graph go down 3. So we could sketch the graph. It would have its vertex that would normally be at the origin. It'll be down here at -3. This one also is a y equal x squared graph. So the basic graph looks like this. But this part makes it go left 2. And so we could sketch that with the vertex left 2. Now if you needed more accuracy, you could let x equal 0 to find where it intercepts the y-axis as well. This one has a few things being done to it, but it is the basic y equal x squared graph. So our basic graph looks like this. This one makes it opens down. This will make it wider than the basic graph. This moves it right 4. And this moves it up 1. So if we wanted a sketch of this graph, we would go right 4, up 1, and that's where our vertex is. Then we have to open down, and it's going to be wide. So we could do a sketch like that then. This basic graph is our square root graph that looks like this, but this moves it right 3. So a sketch then, we'd go right 3 and draw our basic. And again, you could put 1 point to the right and then 1 point up would give you a specific point that you could plot. This one is our basic square root graph, and this tells us to go down 3. So we have down 3, and instead of going up here, I would go here. This is our absolute value graph. And we're going up 3. So we have our vertex up 3, and then we have our line with the slope of +1 and -1. This one, the minus, means it opens down, and it is the absolute value graph, so this is our basic graph. The 2 says our slope is ±2. This tells us we're going right 3, and this says up 1. So if we go right 3 and up 1, our vertex is there, and then we're going to open down, but we want a slope of 2. So this time we want to go down 2 and left 1, or down 2 and right 1. So our absolute value graph shown here looks like this. This one has, it's the 1 over x basic graph, so it looks like this. And it has asymptotes at x equal -2 and y equals 0. So we have x equals -2 and y equals 0, means that we're basically moving it left 2, and so our graph looks like this. This one has an asymptote at x equals 3, and we're going down 4, and the basic graph is this one. So asymptote at x equals 3, down 4, and then draw our graph. Now this 2 is actually a stretch. Since it's 2 times that, I go right 1 and up 2, and that's the point on our graph. Or left 1 and down 2, and that's the point on our graph, if you need more accuracy. And then this one, the basic graph, is our x squared graph, which looks like this volcano type thing, but it's going to be up 1. Up 1. My asymptote then is going to actually be at 1.